Hello, how y'all doing today? My name is Bernie Thompson, and today we're here to take a look at this 1997 Chevrolet K1500. This vehicle has a 5.7 V8 in it and it's misfiring. The shop that brought it to this shop has already been trying to fix this misfire, and they put all the plugs in, wires, cap, rotor, PCV, fuel filter. Car is still missing, so they put parts on it, but they're not finding the right part to get the misfire fixed. So what we're going to do is we're going to diagnose this car so we can fix this misfire. First thing I want to do is put a scan tool on this vehicle and get some basic data. So let's go ahead and get that scan tool installed. Okay guys, I got the scan tool connected. We're bouncing the fuel control up and down. The total trim is okay. That's this one, and the long term is this one. They're both green, so we're okay. But bank to bank fuel trim, it's found that we're 7% out, and that's quite a bit bank to bank. We're warming slowly, and we're only at 134 degrees, but I just started it. The engine vacuum is okay. It's at basically 16, 15, 16. I'm a mile high, so that's about what I expect on a car here. We've got good charging system, and we got a DTC set, and the monitors have not run, and we already know they've been working on it, so that just tells me they've cleared the codes. That won't matter to us. Okay, we have a code, a P. Let me show you how we got the scope set up on this K1500. Okay, on cylinder 1, I have an inductive clamp. This is going to go to channel 2 red, and that's on cylinder 1, and this is an inductive clamp, so the only thing that this is going to read is the voltage or the current going to the spark plug wire. It gives you a really good trigger. Then channel 1 yellow I've got on the control or the negative side of the coil, and then channel blue I've got on the positive, what feeds the coil, so we could see if we had a voltage drop. And then the ground is connected to the negative side of the ground on the battery. The only acceptable place to put your ground when you first start working on a car, because you don't know if your grounds are good or bad, but you always know the battery has the lowest potential. Let's go for a test drive. Okay, I got the scope set up. So on channel 2, it's my trigger. I've put a 20 amp, so I'm multiplying it, so I got a bigger trigger point, so it's easier to see, and I zeroed it. Come over here, so we're connected. We're not connected with channel 3, so that would be red, that's correct. Rest of them are. So now this is, the yellow is my ignition, that's the primary. The red is my trigger, so that's 1, 1. So if I wanted to get a trigger, I could come over here and we can put our cursors on this, and then we come here. My firing order is 184366572, so we'll mark that. Now each one of these is marked, so when I turn it back on, now I can go look at the primary and it will be identified by the cylinder. We can zoom in down here and we can look at individual cylinder fire. So our point of plasma, our burn, the kick, and the recover voltage, or this downward kick, is how much energy is being reabsorbed. And then the oscillations, the bigger this down is, the harder it had to fire the ignition. We'll look at this once we start to drive the car and it's missing. Right now, the car is not missing, so we're not worried about this. We need to go drive the car now. Okay, so we're out on our test drive. Since this is an ignition, I'm going to go to fast capture. I'm going to start getting it under fast capture. I'm going to see if we can't get it to miss here. So I can feel it missing right there pretty good. That's interesting. I can see a secondary signal here coming up. So let me show you. Let's shut this off. See how wide these ones are? This is the main ignition from one. But that pickup is picking up a second one right here. But it only can pick up if it's got energy in that wire. So that isn't because I'm near it or anything. That's something else. Like that's bleeding over into one. So that's 3. So cylinder 3 has something going on because I can see it when it happens. So let's come back out here. And again, we can see how high this is coming up right here. And these type aren't capacitive clamps that will show an indication. It only picks up what's in the wire. That's why you use it for a trigger. So here again, we've got 3 again, showing that 3 has got some kind of energy. When I fired 3, I'm seeing it in the pickup for number 1. And we can come down here and we can see what we can see here. This cylinder is pretty lean right there. You can see it kicking up, like it's got some leanness. These are normal with some turbulence in them, and that's lean there. That would have been 3 there. That's not it either. I don't really see anything that looks that odd with this one. But I have seen on these distributors where if the rotor doesn't point at the cap correctly, because he's got a really weird cap on him, that it can start on one cylinder and then the spark can move to the next cylinder because the rotor isn't pointing correctly. I can't remember. I've had this happen. It's been 15, 20 years ago, but I know it has to do with the rotor. I think a couple of these I've seen caps burn through, but I don't think that's what's going on here. It's almost like the rotor's not pointing right. So we'd need to go and check the timing, and you do that, I think it's through the cam timing on a scan tool. I think it needs to be 0. And that says that it's pointing, the distributor's clocked right. But when I've seen this in the past, it has to do with where the rotor's pointing inside that distributor, and it starts to spark on one cylinder and then it can go to the one right next to it and you can get a misfire and you can get energy put through the leg like this. And I do believe that 3 and 1 are next to each other on the cap. I'm not sure of that. We'll have to go back to the shop and look at that. But for surely we have a problem. So I want to get it to do it again. Let's see if we can't get it to miss again here. So it started to miss there. So let's just see what we got here. So right over here, we can see these big strikes over here. And again, that's 3, cylinder 3. So one's pickup is picking up energy when 3 is firing. That's what we're seeing here. And I've seen this on these engines before where the distributor is not clocked correctly. And if it's not clocked correctly, it'll fire part of that cylinder and then it moves over and it starts to go through the other cylinder. So you're actually firing 2 cylinders, but it's not enough energy because all that energy needs to go across the spark plug to fire that plug. If it's going across 2 plugs, you get misfires. So we can see it doing it again. So let's do this again. So it started to miss pretty good right there. Let's just see here. You can see the strikes right in here. It's the same cylinder once again. It's that 3 cylinder. Let's get our cursors. See, we're getting 3 again. We got energy in that wire when one's pickup is picking up for 3. So the only way that picks up is if energy is going through the wire for this trigger, this type of a trigger. And we can see when we're not having the miss, like over here where I was letting off, do you see how we've only got 1 spark, 1 on 1? That was where I let off when I was trying to stop, and it's not doing it. Over here is where I got a miss, and we can see the difference right away. See how clean this is, and see over here how we start to get a bunch of, we get another big spark here that's occurring. Okay, so what I think happens is, the reason it happens at about 2000 is when we start to get advance. The rotor, because the advance starts to happen, is in a different position and it will arc over to one of the other cylinders. So one of the things I want to try really quick here, so I want to come over here. We're going to pick the ignition timing for 1, and then we're going to go to the scope, open up our multi-tool. So that's my advance. So let's see if we can see the same thing happen here. We got 34. Boy, it started to miss. When we got way up on our timing, I could feel it miss. Let's try that again. It's missing. It's missing. It's at 35, 37 degrees when that miss starts to happen. So we can see that the scan tool indicates that we got full advance when this problem occurs. We can come in here and we can watch this. And we can see that it's got an extra strike there. We can see these extra strikes in here for sure. Right in here, and it's that same cylinder that's got the arc. And it's when we're getting a bunch of advance. The advance is given right up here, guys. This is my advance curve. Let's watch this again. It missed a couple of times as I took off there. Now it's missing. So we can see these big spikes right here where we got energy in another wire. So we got 2 wires that are being energized at the same time. I'm firing 3 here, but I'm getting part of that spark is in cylinder 1. Now the wires can also, if the wires are too close together, they can couple and you can crossfire through the wires. But on these cars, I've just had problems that are very similar to this, and it usually isn't the wires, it's in the cap. This has got a really different kind of cap and distributor in it. We need to go back to the shop and just check where that rotor's pointing right now. Let's see what's going on with that rotor and where it's pointing in the cap. Okay guys, I got an enhanced scan tool and I've got the camshaft position retard. This is how you basically set the timing, and this should be at 0. We're at -10. Now, it's been a long time since I've done these cars, but my memory says at 12 or 15 it sets a code, so this is right below a code threshold. But this tells me that the distributor is not stabbed correctly. So now is what we need to do is go check how that distributor is stabbed in this motor. So let's go ahead and check that distributor. Okay, so what I want to do is take the number 1 spark plug out and bring it up on top dead number 1, and then check the rotor position to where it's facing in the cap. Yeah, the plugs look new, just like they said, but let me go ahead and get this up on top dead center. Okay, so I've got a borescope in the hole. We can see the piston. And now we're going to just bring that piston up. Go ahead. Keep coming. Keep coming. Now we can see when we're going to get to top dead center. It's going to be quite simple to see. Now that won't be true top dead center because that'll just be when the piston hit the top of the bore, but the crank won't quite be in top dead. Keep going. Okay, that's top dead. We've hit the top of the bore. Keep going, Pat. Then we're going to go back. You're still coming up?
Okay.
So, which way are you going?
Clockwise.
Still the same way, right?
Yeah.
Okay.
It's just very...
You're going down now. Go back a little bit the other way. So come back up on it. Okay, you're there. That's top dead. That's really close to top dead right there. Close enough to line the rotor up. So now we'll get the cap off and take a look at where that rotor is. Okay guys, look at this. The distributor's worn out. That's the gear. Do you see that rotor moving around? See how much it can move? Look at how much that moves. Well, that's going to be moving around when it's running, and then this doesn't line up with the right terminal on the cap. That distributor is shot. I think that's the drive gear. We're going to need to pull that distributor out of there, but I think the drive gear is flat worn out. See how much that's moving around? Well, that's moving around, and that's making that spark jump to the next tower. And those two wires, the ones we're having problems with, are right next to each other. That's why that was arcing like that. But we're just seeing it in this one wire, but I think this is doing this on other cylinders as well that are next to each other. We just don't have the inductive clip on the other wires to see it. We see it on one. Okay guys, we're back over. The shop has finished the vehicle. They put a new distributor in this vehicle, and the distributor fixed it. Now they bore scoped, they put a bore scope down and checked the cam gear, and the cam gear is a little ripped up, but it's not knife edge. It's nothing like the distributor gear. Goes to show you the distributor gear is purposely made softer than the cam. The cam is way harder, so they could put a new distributor in and it'll be okay on this car. With the new distributor, the car now sets up the cam retard to 0, and there's no misfires in this car at all. You got to think about, at some point we got to start to actually diagnose these cars, because you can keep putting parts on. You can put injector spiders in this car. You can put fuel pumps. You can put plugs and wires, cap, rotor, PCV. You can put all the parts, and it's going to still misfire. At some point, we got to start to troubleshoot these cars. And the way to troubleshoot these cars is with an oscilloscope and a little bit of knowledge. In all the videos that I lay out, I do the same procedure in all the videos I do. I'm trying to show you how you too can be very successful diagnosing cars quickly and accurately at your base. And basically, that's using a basic scan tool and an oscilloscope. As you can see in these examples, I work on some of the hardest cars that you can imagine, and I'm fixing these cars with an oscilloscope and a basic scan tool. Now, on car lines that you do a lot of, have an OE factory scan tool. You need them, but you can't have an OE scan tool for every single car line that you work on. It'd be really expensive, it'd be really hard. I have all the OE tools, but as you can see, I'm not using them when I'm diagnosing these hard cars. I'm using a basic scan tool and an oscilloscope, and I'm very successful at diagnosing, just as you will be. Get an oscilloscope and put some time in it. It's not easy. You're not going to just get an oscilloscope and you're going to understand what it's telling you. But if you put the time in, you too will be good. Anything you want to be good at, you got to put time in. If you want to be good at skiing or shooting or riding your motorcycle or your bicycle, you got to put the time in. At some point, you're going to want to be good at doing your job. And that means to put the time into learning how to diagnose stuff. And that really is going to be an oscilloscope is the way to do that. If you have an oscilloscope and you have it and you use it, you too will have good troubleshooting in your base.